Yeah. Well, come talk to me. All right, let's go through. Well, let's hit those first two questions on that homework first. We kind of just touched upon them, but then we didn't have really enough time. So let's go. I'll go down to the end. All right, so I'm looking at number 15 and number 16. So number 15 does this as a graph. And I might not have it exact, but I think you get the idea. So some points that are valid right here, that would be the point -3, 0. This would be the point 0, 3. And that looks like 1.5, comma 0. And maybe down here, that point looks like 1, 2, 3, 3, -3. Okay, so we have this graph, and it says, give the domain and the range. Give the intervals on the x-axis where the interval is increasing. Give the intervals on the y-axis where the function is positive. Okay, so there's a lot of information there. So things that we need to talk about. So we had said the domain goes with the x values and the range goes with the y values, right? We said those were alphabetical, so we can use those over and over, right? Okay, so looking at this graph, would you think that this would continue this way and this would continue this way? Meaning, on your paper, does it look like there's a solid dot ending the graph? No, I think this graph will continue to go forever. So I think that it's going to continue this way and it's going to continue this way. Is that all right? So what is the domain of this graph? So if this is continuing to go this way, how far is it going to go that way, would you think? Infinity in the negative direction. And then how far do you think it's going to go this way in the x direction? Infinity. So our domain on this, it appears, would go from negative infinity to positive infinity. Okay? And those are just the x components, meaning if I was walking along the x-axis, if I was coming along that, it's going to, we were just walking along that, we have the graph that's existing above or below us or right on the line. Okay? The range now, okay? So being that this is appearing that it's going forever in the vertical direction up, and this is also going in the vertical direction up, it's going to go upwards to all the way to infinity, because this is pointing upward and this is pointing upward. It's going to get to infinity. But what does it look like our lowest y value would be? And before you answer that, let's determine all of our y values. I have a y value here, y value here, y value here, and a y value there. So what's the lowest y value that we have? -3. And do we include it? Is it a point there? Yes. So it's a square bracket. So our domain, because the arrows are going off into Never Never Land, and the graph happens to be going, just continuing from left and right, that will go negative to positive infinity. The range, though, because both of the arrows are still pointing upwards at the end, we have to just figure out the lowest value and know that it's going to infinity. Okay, so that's the domain and range. Give the intervals on the x-axis where the graph is decreasing. Decreasing is where the graph is going downward, where it's starting to point down here. It's starting to point down there. So as far as decreasing goes, here, because it's pointing down, and here are the two places the graph is decreasing. These two spots are where it's increasing. It's not asking that, but here's where it's decreasing. So using the x direction, using the x direction, you're talking about what it's doing in the y direction. So it is decreasing when it is coming from the x direction out here, so negative infinity in the x direction is decreasing until it gets to the point -3. So you're coming from out here, and B in the graph is coming down. When you're coming from out here, it's decreasing until it gets all the way to here. Okay? I'm not going to include this point. The reason I'm not is because this is a turning point. It goes from turning down to turning up. And there's something that happens at the instant that it happens, and it's actually a horizontal situation. But so as we're decreasing, we are thinking about what's going on in the x direction. So if I'm driving in a car this way, and you're looking up at the graph going, yep, still coming down, yep, still coming down, yep, still coming down, yep, still coming down, and you get to here, it's like, oh, something new happened. So it's decreasing. And then you're still in your car, and you're driving this way. So you're looking up here, oh, it's increasing, it's increasing, it's increasing, it's increasing. You get to here, something's happening. It's decreasing, it's decreasing, it's decreasing, it's decreasing, it's decreasing until you get to here. And then you're like, oh, it's starting to come back up again. Okay, so decreasing is when it's pointing, it's going, the graph itself, as you go to the right, is aiming down to the lower right. Okay, so it's also decreasing from 0 in the x direction, because I was driving along the road, until we get to 3. And that's where the graph's decreasing. Now, guys and girls, there's no one in here that feels 100% on this right now. So don't be like, oh my gosh, what is he not talking about? This is a totally new concept because you're talking about you are going in the x direction, so what's happening in the y direction? The domain is doing this, therefore what's the range doing? Is what we're kind of going with. And then give the intervals on the y-axis where it is positive. Positive means that it exists. So if you're talking about where is our graph positive, it's where it is above our x-axis. So let's do this. Okay? It's positive where it is above that line. Okay? So we're looking for when it is positive. Does anyone see a place where this graph is not positive? Meaning it's below that yellow line? Yeah. Does that make sense? That kind of verbiage? So it says give the intervals on the y-axis, so the y-axis as you go up and down, where it is positive. Okay? So it's positive here. Okay? It's also positive here. And then it appears that this is going to start coming up, but we don't see it. We don't see the intersection. So those are the regions that it happens to be positive. It's above the x-axis. So I'll just put a term in there. Above x-axis. All right, so it is above the x-axis from negative infinity all the way up to, it's like 1.5. And that's about it. Okay? So if I'm coming here on the x direction, it's positive, positive, bounces, positive, bounce, down. So it happens to be positive all the way up to this point. Okay, at this point we could say it is 0 technically. Okay, this is a 0 point right here. Okay, so what we could technically say is straight through this, and we say it goes from negative infinity all the way to -3 as it's positive. At -3, it happens to be 0, and then from -3 to 1.5, it is positive. Of course, I wrote it up. So -3 to 1.5. Okay, totally new concept to think about. But it's how further math classes start talking about what's the function doing at this point. Okay, remember, function at x is what we've been doing. So let's look at number 16. This is something that we are going to work with a lot. This is the first time you've seen it. It's not like, oh, I remember we added fractions together many years ago. No, this is brand spanking new stuff. Okay? So number 16, we have our xy axes. And we have this graph that goes from here to here. Then it comes down, and then it's horizontal, and then it's down. Right? Thanks. Okay. All right. So, being that this graph, we can see where it's terminating. Right here is a point, and right here is a point that it's not continuing. And when you look at your graph versus if you looked at number 15, it just kind of, that's the picture of the graph, and that you're seeing the entire graph. But if you look at number 16, down here, you're going to see that this graph doesn't continue, or over here it doesn't continue, as well as over here it doesn't continue. So those happen to be points. So if I just label these points, I know that's 0, 0. And then if I look at my peak up here, it's 3, 6. Then I look at this point right here. This is the point 5, 4. And this is the point 7, 4. What kind of lines between 5, 4 and 7, 4? I know it's straight, but what kind of straight line? Any ideas? Any idea what kind of line this is? Good. All lines are straight, but so 5, 4 to 7, 4, what does that tell you? It's what? It's constant, so it's a horizontal line. Okay? All right, so let's talk about the domain and the range of this graph. Domain, and again, this is brand new stuff, so don't be like, oh my gosh, I don't get it at this point. You're not supposed to get it. If you do get it at this point, we need to put you to the higher math class, which is okay. All right, so the domain is the x value. So I'm going this way in the x direction. Where does this graph start and stop in the x direction? Doesn't matter where it wiggles around. Where does it start and stop in the x direction? I have the x values underlined. What do you think? Go ahead.
Starts at 0 and ends at 8.
There you go. It starts at 0 and it ends at 8. That's what our domain is. Our range are the y values. So these are my y values. So what is the smallest? Whoop, that's actually 8 points, excuse me. What's our smallest y value? Yeah. What's our biggest? 0 to 6. Okay, so again, the range talks about the y value. So you have to look at the y component and say, okay, the smallest y value is this, the largest is this. Yes, there is a y value at 4, 4, and 1, but they don't happen to be the biggest or the smallest. They're just other point values. Okay? Where is this graph decreasing? I'll highlight it for you. Here it's decreasing, and here it's decreasing. Okay? So it's decreasing. It's aiming down. So look at the x component. So this very first x component where it's decreasing, looking at the x components only, what's the region that it's decreasing? From where to where in the x component? Look at the point, 3, 6, 5, 4. What's the x value of 3, 6? 3. What's the x component of 5, 4? 5. Where is it decreasing from? From what to what? Use the x component to label. 3 to 5. Good. Okay? Now we're going to still use the x component on the other part. So I have 7, 4 and 8, 1. What's the x component on 7, 4? 7. What's the x component on 8, 1? 8. So where is it also decreasing? 7 to 8. That's exactly right. Again, it's a weird concept because you're like, what's going on in the y direction? Well, that's where it's decreasing or increasing. Okay? So again, brand new concept. It was only touched upon briefly the other day. And give the intervals where the graph is positive. There's only one point there that doesn't have a positive component because the point in the y direction is at 0. So, this right here is at 0. Everything else, so where is it positive? Again, we're looking at the x component. So, from 0, but round bracket, all the way to 8, closed bracket. Now let's talk about why one's an open, one's a closed, or one's a square. At this point, this is the point 0, 0. 0 in the y direction is not a positive number or a negative number because 0 is neither. But this is a square bracket because this is a point. Okay? So this is not a 0 because it's 8, 1. It's not 8, 0. So where is this graph above the x-axis? Pretty much from here, not including this exact point, but as soon as I start moving to the right, it goes up, and it gets to here. So from 0 to 8, close bracket on the 8, our graph is a positive graph, meaning it's all above the x-axis. Okay? So what's taking place with this is positive, 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 positive. And we're talking about when it's positive, the y value. Okay? Those are the x values, but your y value at between 0 and 8, all of their y values are some sort of positive number. They are above the y-axis. Total brand new concept. Again, guys and girls, if you're like, I'm still a little bit confused, you should be. Okay? All right, let's open it up to other questions on the homework, though. So we did 15 and 16, and I hope you had written those down. If not, please watch the video and write it down. So let's take a look at problems 1, 2, 3, 4, 5, and 6. Okay? So we wanted to determine if the given relation, remember a relation is just ordered pairs, x, y, whether you're using a table, whether you're using ordered pairs or not. But a special type of relation is called a function when what doesn't repeat?
Number.
What number?
The x
The domain. The domain, good. So the domain repeats. New function. Still a relation, but not a function, not the special kind. All right, so problem number 1, does our x value repeat at all? No, so is the function? Yep. Number 2, x value repeat at all? It does. Is it a function then? No. Problem number 3, does our x value repeat at all? No. Negative 2 and positive 2 are not the same number. So number 3 is a function. Number 4, does our domain, our x value repeat? Yes, it repeats every time. Not a function. Problem number 5, I have 2, 3, 4, and 5 as my x values. Do they repeat? Function? Yes. Number 6, I have my x values is 3, negative 2, negative 1, and 3. Does the x value repeat?
Yes.
So is it a function? No. Problem number 7, is it a function? No. What test does it pass? Which line? Right, what's that one called? It starts with a V. Vertical line test. So if I can draw a vertical line anywhere on the graph that touches it more than once, it means it's not a function. So number 7, not a function. Number 8, what do you think?
Yeah.
It is. That's an exponential function. Number 9 is a circle. Function or not?
No.
Nope. Number 10, that's a straight line. Vertical line passes. Yep. Number 11, it's not. That's a hyperbola. Okay? It's one of the conic sections. Number 12 is a parabola. It's also a conic section. Number 9 is also a conic section of a circle. But number 12, does it vertical line pass?
Yes.
Yep. So the ones that are functions are number 8, number 10, and number 12. Number 7, number 9, and number 11 do not pass the vertical line test. So they're not functions. Okay? Create a relation that is a function, you have all kinds of answers. As long as your x value didn't repeat, you did it correctly. Number 14, create a relation that's not a function. if you can show one of your x values is the same, and again, I'm not reading off any answers because your answers are different. Okay? So as long as the x value does not repeat, you have a function. If it repeats, it's not a function. They're all still relations, but they're not functions. 15 and 16 we've done. Any questions on 17 through, let's do 17 through 26 first.
Number 20.
Number 20. Number 20 says g at 3. So they tell us our g at x equation is this. Right? Okay, so at g at 3, I'm going to substitute 3 in where my x value was. So there was an x value there, now I'm putting 3 in because of that 3. All right, so order of operations, 2, 3 minus 3 is 0. 0 squared is still 0. 2 times 0 is 0. So at g at 3, I get the point 1. So this would actually yield me this point, 3, comma 1, because that's an x and a y value, which this y value can also be the f at x or g at x or whatever, h at x or whatever we want to call it. Okay. Any other questions up through number 26? Yeah.
Oh wait, never mind.
Okay. Anything else up to number 26? The reason I'm just going up to, yeah, go ahead. 24, okay. Number 24, they're asking us g at negative 1. So we're going to use our g equation. So we have g at x equals 2x minus 3 quantity squared plus 1. So g at 1, or at negative 1, is going to be 2 times negative 1 minus 3 quantity squared plus 1. Okay, this was our x value. We're plugging 1 in. So I get negative 4 quantity squared plus 1. Negative 4 quantity squared is 16 if I square it. So I get 32 plus 1 is 33. So again, this yields me the point negative 1 comma 33. Any other questions up to number 26? Yeah. 19. 19. We want g at 0. Okay, so our g at x equation is the same one we've been using. Okay, so g at 0 is going to be 2 parentheses. There was an x there. So this was our x. 2 times negative 3 squared plus 1. Negative 3 squared is 9. Positive. So that gives me 18 plus 1, so I get 19. So that yields me the point 0, comma 19. Anything else up to number 26? All right, let's take a look at 27, 28, and 29. 27, 28, and 29. Do you want them all? Do you want just some? Go from all? All? All right. So these are a smidge different. They tell us that you have the function f x is equal to 22. Well, the f at x equation was this. So being we know that 22 is the same as f at x, I'm going to plug 22 in right here. It replaces it. Notice there's no longer an f. Is that okay? Now it's a two-step equation, so subtract 4 from both sides and divide each side by negative 3. So this is an x value, agreed? So this is the point negative 6, comma 22. Problem number 28. I want you to find, they tell you that h at x is equal to 10. So our h at x equation is 5 times 2 raised to the x power, which is an exponential function. Okay? Being that h at x is equal to 10, I'm going to plug that in right there. So I get 10 equals 5 times 2 raised to the x.
Ew.
Okay? All right, now this is a little different. I have 2 equals 2 raised to the x power. The x is an exponent in this case. So let's think about exponents. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So on and so forth. So this is looking for what exponent is this 2 to give me this. What do you think? 1. Yep. So that's a little trick. So x equals 1 there. So again, this would have yielded me the point 1 comma 10. Number 29. Number 29. G at x is equal to 33. And our G at x equation is this. Okay? So I'm going to take this and I'm going to plug it in for that whole value. So I'm just substituting it in. 33 is equal to 2. X minus 3 squared plus 1. Uh-oh. All right, let's go. Minus 1 minus 1. So that's 32 equals 2x minus 3 quantity squared. Let's go down a little bit. Divide by 2, divide by 2. So, extend the page. That's 16 equals x minus 3 quantity squared. Ooh, okay. Shoot. I think we can figure this out logically. What number squared gives me 16? 4. So what number do I have to plug in here that would give this an answer 4 as a base? 7. Good. Yeah, 7 minus 3 is 4. 4 squared. Okay, so x equals 7 on this. So we are able to do it logically without knowing how to do the math. We just logically went through it. So we get the point 7 comma 33 as our answer. All right, what do you think? Happy day? If you would, let's go ahead and pass forward your homework. Make sure your name's on it. If you're passing anything old forward, please make sure we get it. So again, guys and girls, a lot of this stuff is like brand spanking new. So I video for a reason. So sometimes you can refer back to it if you need to. There might have been a couple of you that still need to finish the test up, okay? Or you need to complete the test. You need to come see me. I don't know when your off periods are, but you're allowed to come into, like if you have third period off, you're welcome to come to my third period class and do it. If you're off first period, come to my office straight down the hallway, which is West 439A. You can do that. That's before school and first period. If you're off fourth period, I'm also off. So my office is, again, West 439A. Today I do have Creek 101, so I won't be there today, but the rest of the week I will. And then if you're off fifth period, you can come to my classroom, which is downstairs across the hall. Next period, I'm downstairs, one this way. Fifth period, I'm downstairs across the hall. So you'll figure it out. Just find me. Just come on in saying, hey, it doesn't matter if you're interrupting the class. You're fine. You're my kid. You're allowed to do that. So that's what I have for you. Everyone feeling okay so far? And I would like to make sure we have those tests made up by the end of this week, please. Why don't you talk? You're good. I was just trying to cover everybody. There you go. All right, let's do some notes. All right, graphing linear functions, number 2. And it is more about functions, so remember, thank you. Can't count these days. All right, so determine if the relation is a function. Remember, relation is just something you could make into ordered pairs. So, is input 0, 1, 3, 2, 1 function or not?
No.
Why not?
The one repeats.
So, because our domain repeats, it can't be a function. Problem number 2, our input is 0, 1, 2, 3, 4. Function or not?
Yes.
Yes. The x values, the input, the domain, doesn't repeat. Determine if 3 and 4 are a function. What do you think? Vertical line test works all the way through. So is this a function?
Yes and no.
Yes, and then this one, the vertical line test doesn't work. If I do that, it touches it twice, so it's not a function, right? So number 3, yes, function. Number 4, no, because the vertical line test happens to touch twice if I draw that in. Oops. Number 5, what do you think? Function or not? Vertical line test work? What about number 6? Does vertical line test work? Hey, what does this open dot mean right here?
It's like an
So it's an open dot. I don't include those points. So 2, 3 does not exist on that graph, and 4, 5 doesn't exist, but that's okay. So yes function, vertical line test passes on both of those. Happy day? All right, the function 2x plus 1.5y is equal to 18 represents the number of book raffle tickets, and x, raffle tickets x, and the food raffle tickets y you buy at a club event. Okay, so you have raffle tickets, 2 different types. There's book ones and there's food ones. Okay, solve the equation for y. If I had this, 2x plus 1.5y equals 18. What do I need to start doing to get y by itself?
Subtract 1.5.
Not yet. No. I want y by itself.
Alright.
So I'm going to subtract 2. Okay? So those cancel. So I get 1.5y is equal to 18 minus 2x. Agree? And then how are these being held together right now? Multiplication. So I undo multiplication by dividing. So 1.5 divide everything by 1.5. So I get y equals 18 minus 2x all over 1.5. And we just solved it for y. Is that okay? Make an input and an output table to find the ordered pairs for the function. Okay. So an input and output table, which is x and y, right? And I was also thinking about this. Remember I said domain and range are alphabetical? Input and output are also alphabetical, so pretty good stuff. All right, so what values should we pick? Well, I don't know. Pick maybe like -2, -1, 0, 1, and 2 to start. And let's see what happens. So I could plug these values in here and then solve for y and get my y component. Or I could plug the values in for here, and that's already solved for y. So we might pick here. So let's take -2, plug it in. What is -2 times -2? Positive 4. 18 plus 4? 22. 22 divided by 1.5? I don't know, 22 over 1.5. And we could, if we had a calculator, I guess, work that out, but there's no reason to worry about it right now. All right, same thing. We're going to take number 1, or -1, plug it in. What's -2 times -1? Positive 2. 18 plus 2 is? 20. 20 divided by 1.5? 20 over 1.5? I don't have my calculator out, so I'm not going to worry about it.
First one was like 14.
Oh, okay.
Point.
0, plug 0 in. Negative 2 times 0 is? 0. 18 minus 0 is? 18. 18 divided by 1.5 is 18 over 1.5. And again, if you had a calculator, you could totally do that, no problem. But I don't want to think that hard right now. It's a Monday morning, for crying out loud. All right, let's plug 1 in. Negative 2 times 1. Negative 2. 18 minus 2. 16. 16 over 1.5. I'm tripping. I'm sorry. And then let's plug 2 in. Negative 2 times 2. Negative 4. 18 minus 4. 14. 14 over 1.5. Okay. All right, now, quick question. Do you have, someone have a calculator? You do? Go for it. All right, what is 22 over 1.5? Please.
It's like 14 point.
Like
14.6 repeating.
14.6, all right. So we'll call it 14.7 because you said it's repeating, right? What is 20 divided by 1.5?
13.3 repeating.
13.3 repeating. What's 18 divided by 1.5?
12.
12? Oh, okay. What's 16 divided by 1.5?
10.6 repeating.
10, so we'll call it 10.7, okay.
Yes.
What's 14 divided by 1.5?
9.3 repeating.
9.3 repeating. Cool. All right, so plot the ordered pairs on a coordinate plane. Let's draw a coordinate plane, do the best we can. So I got negative 2, 14.7 is way up here. Negative 1, we're at 13. 0 is at 12. 1's here. It's a straight line. Let's just pretend I can draw straight. Don't have the older person jitters. Is that okay? So again, you might have to use your calculator sometimes. Let's see. Oh, okay. All right, hang on. We have a graph that looks like the letter V, kind of. This is actually called an absolute value graph. So for what values of x is g at x less than negative 1? Okay? So g at x, where is it less than this? You want to be below it. So what values of x? What about here and here? So at negative 4 to positive 4, our function has a value that is less than negative 1, meaning it's down here. Okay? Right at those values is exactly that. If we had the equal sign, that would have told us to make square brackets, but it's a less than sign. Find the value of y that corresponds between 1 and 3. Find the values of y that correspond between 1 and 3. So at and equal to. So I have 1 comma negative 4. I have, oh, wait. What did I do? That's a negative 1. It should be right here. I'm so sorry. So 1 comma negative 4, we're working. And then if I go at 2, looks like negative 3. And at 3, we are at negative 2. Why did I use square brackets there? Because we're equal to it, right? We're talking about that point there, that point there, that point there. So I guess if we're talking about points, we could then say, you know what? They should be rounded brackets because a point is a point is a point. But if you started out with square brackets, you're okay. Find the values of y that correspond with our x being less than 2. So our x being less than 2. Is there a whole bunch? Oh, wait. Gosh. quit sniffing paint. It's greater than 2. Jeez. All right, so values that is greater than. So find the values of y that correspond with x is greater than 2. So I'll go with 3 comma negative 2 at that point. 4 comma negative 1 greater than 2. 5 comma 0. I guess you could throw on there 6 comma 1, which would be like right there. What is the domain of g at x? Goes forever left and right, so it's negative to positive infinity. What is the range? Well, it's pointing up, so it's going to end at infinity. What's my lowest value in the y direction? Right there. What is the y component of that? What is the y component? The x component is 0. What's the y component? Negative 5. Okay? So the range, and we can start with a square bracket because we include it. And then we're looking, where is this whole thing decreasing? It's decreasing right here. Okay? So if it's decreasing from negative infinity to 0, and we'd be done there.
Isn't it increasing?
Decreasing meaning it's heading. Oh, it says increase. Oh, thank you. It's increasing. So that was decreasing, yellow. Increasing goes from 0 to infinity. Oh my gosh, thank you. So there's it's increasing. All right, so guys and girls, tonight I'd like you to work on page 51 and page 52. Have a great day, everybody.
Thank you.